Hi everyone. I want to talk to you about domain and range. So this is the beginning of the next unit that we're going to be looking at. It's going to actually deal with some quadratic stuff, so maybe some of this will actually seem familiar to you. To begin with though, let's talk about domain and range. If you go into your Google Classroom, there is a Desmos activity that's posted there. I'd like you to go to that and do the activity, and then once you're done the activity, come back to this video. All right, so hopefully you've completed the activity in Google Classroom. So now we're going to take a look at domain and range. The domain is the set of all input values in a relationship. So think about it as what can go into. So usually those are your x values that can go into a function or into an equation. The range is the set of all output values of a relationship. That means if I substituted let's say a value in for x into my equation, what would be the value that I would get out? Usually a y value. And so that is the range of all outputs in a relationship. We can state the domain and range using what we call set notation. So for example, if we consider what's on our left-hand side, the domain, so if we put in a 2, then we would get a 4 out. If we put in a 3, we would get a 6 as our output. If we put in a 4, we would get an 8 as our output. And if we put in a 5, we get a 10 as our output. So our domain then, using squiggly brackets, tells us that what we put into our relationship must have been a 2, a 3, a 4, and a 5. Now, what we got out of the relationships, that's our range. So those are our outputs. And in this case, our outputs were 4, 6, 8, and 10. Inputs are our domain. Outputs are the range. You'll hear me say this over and over again. All right. So let's say we were talking about more relationships and set notation. So here we have a table, and we can write this table of values as you can see here, or you can write them as coordinate points. So if I was going to talk about my domain then, my domain would be all those inputs. So those would be all our x coordinates. So 2, 3, 4, and 5. And my range would be all of our outputs, which would be 4, 6, 8, and 10. We can kind of think of it as domain under our x values, range under our y values. Now, let's say we take a look at this example. State the domain and range for this relationship. So instead of writing it as a table of values, they've written it this way as coordinate points. But that's okay, because we know that our domain is going to come from all those x values that we see. So let's see what we have. We start with a 3. And then in the next set of brackets, next coordinate points, I have a 4. And then the next coordinate brackets, I have another 4. Okay, so when there's duplicate inputs or duplicate outputs, we do not write them twice. Once it's represented once, then we stop. So in this case, I'd write a 3, I'd write a 4, but I would not include another 4. I would continue on and look at the rest of my inputs. I have a 5 and I have a 7. So here we go. That would be my domain. Whereas my range is going to consist of all of my outputs. My outputs are my y values. In this case, I have a 5 and a 6 and a 7. Up and another 6. So I am not going to include that 6. And a 3. So here we go. Now you can leave it like that, or most commonly we like to write this in numerical order, so I would probably rewrite this as 3, 5, 6, and 7. But if you didn't, it's not wrong. It's just how we kind of mathematically like to write things. Okay, so domain is the inputs, which are usually our x values. Our range is our output, which is usually our y values. What if we had a graph? So if you have a graph, here we have some coordinate points. And so we're going to have to read these coordinate points off. Now, what you could do is actually list your points. So even though these are not numbered, maybe I'll put some numbers here to help us. So let's take a look. I have this point right here, which is at 1, 0. I have the point above it, which is at 1, 2. I have the next point over, which is at 2, 3. And then 4, 3. And then last is at 5, 1. So it could be easier to write your domain and range if you take the time to pull those points off of your graph. Then our domain is simply going to be 1. I have another 1, so I'm not going to include it. A 2, a 4, and a 5. My range is going to be my outputs or my y values. In this case, it's going to be 0, 2, 3, and 1. And again, I like numerical order. I'm going to rewrite this as 0, 1, 2, and 3. Okay, so if you're given a graph, simply just take a minute in order to pull the points off the graph. All right, but what if your graph looks something like this? Well, as we can see, we have a linear line, and this line extends forever in each direction. That's what the arrows mean on the end. The line extends in either direction. So when we talk about inputs of a linear line, so our domain, we can see that actually, if I kind of shade it, if we picked a point off of this line, there's actually infinitely many points, right? There's all these points that lead to our x-axis. So it's almost like shading. And we can see that this goes on forever in either direction. And because of that, we say x is allowed to be anything. But of course, there has to be a mathematical way to say x can be anything. And the way we say it is x, and then we use this, it looks like a C with a little line in the middle. It's called an epsilon. It means x is an element of, and then let's do our real number symbol. So x is an element of the real number system. What that means is that we could use any value we wanted for x. We could input any value we wanted for x, and we would get an output. So I'm just going to put out my squiggly lines on either side. And there we go. So that is definitely kind of different than what we've seen before. But that's what it means, okay? Whenever you have a line, a linear line, we can input any x value we want into that line. We would get a y value out. Same thing if we started shading towards our y-axis. If you notice this y-axis, I'll do this in green. We can easily see that we are going to cover everything here on our x or on our y-axis, which means we can have infinitely many outputs. There's no restriction to our outputs. So I'm going to say my range then is that y can also be any number. So y is an element of the real number system, which simply just means that we can have any output. We can actually figure out any number that would be this line would touch, would give me any output I wanted. Okay, so there's no restrictions on our inputs. There's no restriction on our outputs, which means our domain is any real, x is any real number, but our range is also y is any real number. Okay, let's keep going. Whew, and now we have a parabola. So let me just drag down this parabola so we have space to talk about it. Okay, so again, like before, we can kind of think about this as shading. And if I took this parabola and shaded it towards my x-axis, this part would be towards the x-axis, and then this would also be on the x-axis. And as we can see, it just kind of goes on forever and ever and ever in either direction, which means that my domain must be an element of the real number system. There is absolutely no limits to what this domain can be. But my range, on the other hand, is a little bit different, because notice the highest point of this graph is right here at 1. And then everything else with this graph is below it. Everything else is below. So that graph opens down. So if I was looking for y values, I would say like my y values, my highest number could be a 1, but then all the rest of my y values, if I just start shading over here to my y-axis, you can see that they're all 1 or lower. For example, I would never get an output of the number 2 because my graph never actually reaches a 2 on my y-axis. So we're going to have to write this to show it. So we say y is an element of the real number system, but y has to be greater than or equal to 1. So we're going to start using our greater than or equal to signs. So y, oops, I even wrote that wrong. Y has to be less than or equal to 1 because y is going down. Y is less than or equal to 1. Sorry about that. So we can see that all our y values are 1 and lower. Okay, so they're getting smaller. And that's how we would write our domain and range. Okay, last example for this page. What do we have here? Well, let's pull it down so we can see it. There we go. We have a semicircle. So we're going to definitely have some restrictions going on here for our domain and range. Let's talk about domain first. So our domain goes in between, I'm still shading here, but it goes just my graph, if you think of it, goes in between this -5 and +5. So x is an element of the real number system such that, so if you're looking to write this inequality, always start with your smallest number first. So -5, that's my smallest number, it's on the left-hand side. And then it's x is going to be greater than or equal to that -5, but it's actually going to be less than or equal to that +5. So the way I like to remember it is I'm always having my inequality signs open to the right, and I put my smallest number first and then my largest number second. Now my range, if I think about my range here, so my range is going to be any real number such that, so it starts here, my graph starts here, and then it goes all the way up to here, to 5. And then there's nothing lower than 0 and nothing higher than 5. So I'm going to start with my smallest number. So my smallest number is 0. I'm going to make that open to the right. So y is greater than or equal to 0, but it's less than or equal to 5. So that just means my numbers are going in between 0 and 5. Okay, so a lot of this stuff is going to be visual. We can just use our eyes to help us see the domain and range simply just by looking at the graph, seeing where does it begin and where does it end. If there is no beginning and no ending, like we saw on the line, then it's just any real number. But if it actually has kind of a beginning point and an ending point, then we need to state where those are at. All right, so here's just a quick little problem. We're given some parameters, so we're told a few things, and we're going to try to draw a graph that actually represents everything that we're being told. So draw a function that satisfies the following properties. Number 1, it contains the point 2, 3. So let's go ahead and plot that point. So 2, 3 is right here, 2, 3. I'm plotting that point. The next thing it's telling me is that my domain X has to be less than and equal to 4. All right. So my domain are my X values. So I'm going to go to 4 on my graph. I'm actually going to draw a nice line straight down. So I know that I'm talking about everything to the left, of that 4, because I want my X values to be 4 and less. And then my range tells me, so let's do this in green, I want to be between -3, so let's go to -3 on my Y values, all the way up to +5. 1, 2, 3, 4, 5. Okay. So in between the box that we've created, so let me just highlight this box that I'm talking about. So this one right here, this is where our function happens. This is where like the graph exists, is inside of this box. Now all we have to do is just to make sure that we go through 2, 3, but that we hit all our points that we should. So I could start my graph maybe down here in the corner, right there, because it says it's equal to it. So at 5, -3, it can come up and go through that point 2, 3. And then it doesn't matter what it looks like because it can continue on forever in that left direction. Because notice, all it told us was that our values had to stay in between -3 and +5 on my Y's and less than 4. So something like this could definitely work because it satisfies all those properties. There's infinitely many functions that you could have drawn here. So don't get overly excited about the actual graph itself. As long as it satisfies the parameters, then you're good to go. All right, homework, page 12 out of your textbooks, questions 3 to 6, 15, 17, and 18. And do me a favor, try to figure out what an asymptote is. Look it up because we'll be talking about them a little bit later on, and so they're useful to know. Remember, if you have any questions, please email me. I'd love to help you out if you need it.